Hello, let's continue for the depreciation methods under the accelerated approach. The idea under the accelerated depreciation is to try to use some techniques to take more depreciation in the early years of the life of the assets than in the later years to match with the actual consumption of the assets over time. So to achieve this purpose, we created, like people created, and is commonly used. There are two different ways. So let's see the sum of year digits method first. Sum of year digits, the idea is we'll have a depreciation rate decreasing over time. So you can have the largest depreciation percentage of fraction in the early years and gradually reduce to smaller amount in the later years. So the key formula under this approach, as compared to the straight line, I put it here briefly, is there is a fraction calculation, so it's not evenly over time. In the bottom, the denominator of the formula, so it's all the sum of year digits. So that's the name of the method. Add 1, 2, 3 until the total years of the useful life of your assets. Or if you have year like 10 years, you add up to until 10. So it's a summation in the bottom. And in the top, the numerator of the formula we need to change over time. Like, this n, for example, in the beginning, like, of the 5 year will be all of the remaining years will be 5. Okay, 5 over 15 for the first year. Then second year, the remaining life will be 4 years of the equipment. So 4 over 15. Then 3 over 15, 2 over 15, then 1 over 15. So it is showing as a decreasing trend for the depreciation we want to take for the assets. So the bottom, you need to decide, okay, calculate and, add up all of the year digits, then from the base, no change. But the top, the numerator will starting from the full, like remaining year and reduce by 1 each year. So if I put this as my, will be like first year, like I mentioned, will be 5 over 15, like basically it's like 1/3, right? Then 4 over 15, second year. Then 3 over 15 is simplified to 1/5. Then 2 over 15, and the final year will be 1 over 15. Oh, again, I know I need to drag down to, because the initial is like the acquisition date. So the rate again, I put it in. So let me also, yeah, zoom it. Okay, yeah, so you can see larger. So the depreciation rate under the accelerated approach, you need to have a trend by the technique you chose to show a decreasing over time, okay, over the years. And the book value or the depreciation cost, still this one is the same as the straight line. Okay, be careful. The original depreciation cost on the sum of year digits is the same. We need to consider the residual value. Okay, I will again put the depreciation cost or depreciation base. So we have the base and now you have the depreciation rate. Now we can do the calculation of the depreciation expense each year. We need to apply this book value to each of the years, okay, by using a declining rate. So first year, I'm using, so this one I will, if I use formula, okay, I need to put it fixed. So this number will not move. So this is $K and $8. So it's referring to this one, and it won't change when I move on to other rows or columns. Okay, when I copy and paste the formula, this value will be fixed. So that's I couldn't just use like referring to K8. Okay, that's another Excel trick. The multiply, but the rate will change. Is because of my yeah, I'm taking a integer, so there will be some rounding here. Oh, then you can see I will copy confidently this formula to the remaining of the years. And each year you can see they are referring to the original cost multiplied by the rate. Okay, so we can see the depreciation expense is going down, accelerated. Okay, so that's a different trend than the constant depreciation expense on the straight line. Now I'm going to work on the accumulated depreciation. The first year is the same as the depreciation expense. The second year, I'm adding this, right? The second year's depreciation to the accumulated. Now I can copy and paste the formula to the remaining. How I can confirm quickly I'm doing the right thing? You see the total accumulated depreciation, not the total. The end accumulated depreciation should equal to your original depreciation cost. So that's a way I can confirm my calculation so far is right. And now I work on my the book value. Okay, again, I can do this. So there are two ways. So you can use your prior depreciation, like depreciation cost, minus the annual depreciation, or use the original depreciation cost minus the accumulated depreciations. So I will do this again to fix this value. K and $8, so it's referring minus the accumulated depreciation, right? So that's again, that's because of and then I'm dragging down to the bottom. You can see again, it's reversing. So accumulated depreciation is going up, but book value is going down to 0 in after the final year. Okay, so this is the accelerated idea we implement. Use a decreasing annual depreciation rate. Okay, sum of year digits. So again, something I want to emphasize first, the depreciation base of sum of year digits is identical, in the same way we consider the salvage value. And each year you are taking a decreasing portion of your depreciation cost as your depreciation expense. So the formula is critical, remember this. But annual depreciation, is you have the most in the early years and sliding, but eventually bring it up to your depreciation cost. And so this is the side-to-side comparison, okay, with these two methods. And now let's move on to the final one. So another accelerated approach, but using a different idea. For this one, the depreciation cost, be careful, there is no salvage value considered. So I want to really emphasize this and give another enhancer. So you don't consider the salvage value in the beginning, and we have a constant depreciation rate, but double the rate we use under the straight line depreciation. So I'm using twice. Okay, this will be the same. So the double declining is not changing is really not changing the depreciation. The rate will be the same over years, but doubled what we use on the straight line. So I will put this 30% first. Some later years we need to adjust. We'll see that in a minute. Okay, but so far, constant double depreciation rate. Okay, I need to delete this. Now I'm doing something similar. Okay, so figure out the annual depreciation, apply the double the depreciation rate with the original depreciation cost. So this one is times. So year one, depreciation 40% rate multiplied by the original depreciation cost. Then depreciation accumulated, okay, for the first year is equal. Then this one, okay, I'm using, this is still dollar Q. I'm holding this too long. And dollar, sorry, it says it's going to Chinese. Dollar Q and $8. I have an extra. So it's referring to this value minus the accumulated depreciation, right? So that's the remaining. Oh, so your book value. But now for the second year, I took depreciation. Be careful. I'm changing my base. Okay, this one will be not using this original, okay, multiply by the 40. So if you do that, you will have same depreciation. It cannot become average. But I'm using the remaining book value, okay, multiply by the same rate. So the declining achieved under the double declining is like I'm using a constant rate, but the declining book value or depreciation base to get a accelerated depreciation, right? Because the 40% apply to the highest depreciation cost. And I believe we can do this continuously. Okay, I can do this. Let's do the accumulate depreciation. Okay, first this one plus the new and the book value will be evenly reduced. And now you can see it automatically comes to my annual depreciation for the third year as long as I figure out the remaining book value. I will continue on my calculation of the accumulated and now my remaining book value and continue. Okay, like see this the accumulated depreciation and the remaining value. Yeah, I think we are almost done here. Did you see this? There's something wrong. Okay. I need to identify this. So at this time, okay, if the remaining value, so for the problem of the double declining, along, in the last couple of years, you need to be very careful. So because, we need to have a 8,000 residual value by the end of the life of the assets. So if you continue follow this 40%, so let me double check everything is right. In the final year, like, in this case, I need to manually adjust because you can see I need to leave a 8,000, okay, for this one. If I continue this 40%, this one is larger than my 8,000 of the residual life, which we estimated. So in that year, if the final year or like the prior year will leave you something different, I will do this. Okay, I will make adjustment and first the remaining value to 8,000 and adjust the depreciation for that year to whatever we need. Okay, to like the original book value minus the desired residual value of the assets. So this one, okay, I will put again a different color. So this is a adjusted. So the only thing for double declining, you need to be careful in the, final 2 or 3 years of the service life. By some time point, we need to manually adjust if the desired residual value is not as we put in the original estimation. We need to have some manual adjustment. Okay, so it can meet our original expectations. And this problem doesn't exist in the prior two methods because we already took the residual value in the depreciation cost base, but this one is different. Okay, so the rate is constant, but some years and this year the rate won't apply. Okay, in this case, I will put NA. So along the road of double declining, well, you may not need, okay, it's case by case. So, but be careful in the final 2 or 3 years of your depreciation schedule and make the adjustment as needed. Okay, that's the double declining method. So, two permitted approach. You see companies use all of these. Straight line is very popular. Okay, even straight line is still the simplest, but still widely used and also accelerated. And you can choose different group of your equipment assets and use different depreciation method in the same time. Okay, we call group depreciation is allowed under the gap. But you need to let the users know what the group rate or group depreciation method. So that's a time-based approach. And finally, let's quickly get to the activity-based. Activity-based depreciation or depletion is for some type of equipment and is all used for natural resources for depletion. So if you have uneven, if you have uneven usage of the assets, for example, like I have this equipment, so it's not really used equivalently over the life. Then in that case, we can estimate a total production units, right? Like depending on the usage. So what you are going to use for the equipment? For your natural resources production or for regular product units. So in that case, we have a 162, like, total thousand. I put the formula. So total depreciation cost, we also need to get a rate, but this rate is not time-based. Okay, is your production or activity-based. So total depreciation cost divided by the total production units. In our question, this will be like, again, consider the salvage value in the beginning, then divided by. So this will be your depreciation expenses per unit. So per unit of production, like per unit of the bicycles or like the TVs, whatever you use the equipment produce. So each unit or each tons of the gas or coal or oil extracted. So you are spreading the total cost of the assets over the units of the related production. So in my case, like, if I do a calculation, okay, will be, I mean, just put this into formula. Divided. So each unit of the production, like will be 44 cents. Okay, that will be your constant depreciation rate under the activity base. Now, if for example, like 2027, I'm just making up this number. Okay, so assume the production is total is 120,000 units. Okay, early years I produce a lot. So, and in that case, my annual depreciation will be now it will be easy. Okay, just apply this rate, multiply by the actual production units will be 520, $800. So 2017 depreciation. Oh, if for example 2028, like I'm saying like uneven. Okay, like for example, I only made 5,000 units or 50,000 units of production. Similar, I will just multiply the rate by my actual production units. Okay, for the second year, the depreciation expense will be only 22,000, right? So uneven depreciation, no trend, no pattern, just depending on the usage of the equipment. So we call activity based. For depletion method for natural resources is basically only activity based. It's really depending on your the use of the natural resources over your activity levels. Okay, I think this is a summary and a demo for the different depreciation methods. Uh, Please use this to perform like to do your first homework. Let me know if you have any questions. And next Tuesday we'll continue on depletion, amortization, and other topics in chapter 11.